Okay, in this video I'm going to show you how to use definite integrals to determine a change in cost or revenue given the marginal cost or marginal revenue. Because the marginal cost is the derivative of your cost function. So going the other way, if we're given a marginal cost, we can get to the cost function, at least except for a plus c, by computing the integral of the marginal cost. So in this case, we're given a marginal cost, and we'll determine if the so this is the cost per unit. So if the number of units is increased from 151 to 191, then what is the increase in total cost going to be? So that's going to be the definite integral with limits 151 as the lower limit and 191 as the upper limit of your marginal cost function. 141 plus 290. Well, actually, what I'm going to do is, that's 290 over the square root of x, but I'm going to write it as 290 x to the minus 1/2. That way it fits the integration rule that we're going to use here, the power rule. So we evaluate this integral. We compute the antiderivative of the marginal cost. That's going to be 141x plus 290. We use the power rule. Our exponent x is minus 1/2. So we add 1 to that. So we get x to the plus 1/2 over 1/2 with limits 151 and 191. Now I'm going to clean it up a little bit. So this is 141x plus, so dividing by 1/2 is the same as multiplying by 2. So this is the same as 580 square root of x with limits 151 and 191. So to evaluate this, I'm going to need to use a calculator, and we'll round to the nearest cent. So I have so 141 times 191 for the upper limit plus 580 square root of 191 minus 141 times 151 plus 580 square root of 151. Now, I'm going to simplify this a little bit because here we have 141 times 191 minus 151. Then I can have 580 times square root of 191 minus square root of 151. It's worth mentioning that the integral of a constant is a definite integral of a constant is always that constant times the difference in the limits, which is what we see here. So this part could have been done that way much more rapidly. So that's something to keep in mind. The definite integral of a constant is that constant times the difference of the limits. So here we have 141 times 40. So we end up with 5,640. Okay. And then I just need to handle this part. So this, no getting around calculator on this one. So I have, so 191 square root minus 151. Whoops. All thumbs in these things. 191 square root minus 151 square root is only at 1.53 something. Okay, times 580. Okay, and what I get rounded to 2 decimal places is 888.60. So then I just add this to 5640, and what I get is $6,528.60. So that's how much the cost has increased when the number of units being produced increases from 151 to 191. It's worth mentioning that this marginal cost function is a decreasing function of x. So as the number of units increases, the marginal cost is decreasing. Therefore, if I were to increase by another 40 units, say from 191 91 to 231, I would find that the increase in cost to be less because the marginal cost is less over that span. Okay, so we can use a very simple approach to compute the increase in revenue given the marginal revenue. So here's our marginal revenue function, 6.2 minus 0.35 square root of x. And we want to see, because this marginal revenue is dollars per extra unit sold. So if the number of units sold increases from 149 to 264, how much additional revenue are we in total are we going to get from that increase? So that's going to be definite integral from 149 to 264 of 6.2 minus 0.35 x to the 1/2. Once again, I'll write it in that form, use a power rule. Now I'm going to use a shortcut that I alluded to last time. If I break this up into two definite integrals, so 149 to 264, 6.2, and then I'll pull out the constant, minus 0.35, integral from 149 to 264 of x to the 1/2. This is going to be equal to that constant, 6.2, times the difference in the limits, which is 64 plus 51 is equal to 115. So 6.2 times 115 accounts for this part completely. And then I still have a minus 0.35 times the integral of x to the 1/2. Using a power rule, that is x to the 3/2, so we add 1 to the exponent to get 3/2, divided by 3/2 with limits 149 and 264. Okay. Now, so for this part we get 713, and hold on a second. Okay. And for this, dividing by 3/2 is the same as multiplying by 2/3. So that's going to be minus 0.7 divided by 3. I don't feel like dealing with repeated decimals at this point. And I'm going to have 264 to the 3/2 minus 149 to the 3/2. All right, so now we're going to be subtracting something off here, so hopefully what we'll get is still something that that is at least positive. Okay. Now, so what will happen is when I plug in 264 to the 3/2 power, or the 1.5 power equivalently. Okay, that's a pretty large number. It's over 4,000. And then minus 149 raised to the 1.5 power. Okay, that somewhat brings it back down to earth. And then we multiply that by 0.7. Okay, and then we divide that by 3. Okay, so what we get for all this is 713, and all of this worked out to the 2 decimal places, 576.5. So then okay, and what we get is 2 decimal places, 156.50. So the increased revenue from selling an additional 115 items, and that says only additional $156.50. So we don't really gain very much because presumably there's less demand for these items, but more of them are sold. So, so we really gain only on average about a little more than $1 per extra item sold. So hopefully these items are very cheap to make.